Yeah, so I mean, basically, if you have a Cartesian plane, you can plot all the x's and all the y's, in this Cartesian plane here, here, whatever, by sort of notating what the, whatever the coordinates are in the x and the y, and then obviously if you do the same thing with the z dimension, you can do that too. Pick an x direction, pick a y direction, and pick a sort of a z direction, and you have three vectors that explain the location. Now, if you try to do it in 4 dimensions, your brain will get a little messed up. But if you do it in like in a I don't know, matrix notation or something, you say, well, this point exists at 0 and 1. Well, if you just made that a 2D matrix, you know exactly where. Well, 0 is on the y-axis, and then 1 is 1 point higher, so this is the point we're talking about, right? And this is a Cartesian plane. And you do the same thing with 0, 1, 2, or 0, 1, 5 maybe. And then in the 4th dimension, you would add 7. So how do we draw this on some kind of tool like a Cartesian plane or maybe a 3-dimensional plot device? You couldn't really do that. But you can certainly perform mathematical operations, like you can add 2 4-dimensional vectors pretty easily or multiply them or whatever. So how do we think about this 4th dimension, though, in maybe more unique ways? So one of the ways I've thought about it is thinking about, here you have x and you have y. I'm sorry, you have y and you have x. Sorry, a little foolish. And maybe you have a zth dimension going down here, right? And so maybe one idea here is, okay, so on the x we're at 0, on the y we're at 1, and on the z we're on 5. So I don't know, maybe we're somewhere like around here. But maybe for how do we notate 7? So now we're kind of lost because there isn't a 2nd dimension, a 4th dimension, I should say. So let's notate another one, like 1, 3, 6, and 2. All right, so 1 on x is over here. 3 on y is up here, and then in the zth dimension we're going to go kind of like deeper into space, if you will. So we're going deeper on the page, if that makes sense. So here's, this is the 3rd dimension, the z. So this is x, this is y, this is z, and we'll call this q. So what does it mean to go q space? Because we've already gone deep, and if we were going to come into negative z space, it would be coming into us, right? And with positive z, we're going outwards, deeper. So this is just 3 dimensions we're familiar with. So how do we go into the 4th dimension? And I think this is kind of interesting. One of the ways that I thought about it is you don't have to do it spatially. So what I mean by that is if you took this and you made a sound, or you made a color, or some other property, you can sort of think about, okay, well, orange is maybe on the electromagnetic spectrum, visible light. You have something like red, right? Kind of orange. Then yellow, green, blue, etc. And so maybe the best way to think about this, since we can't visualize it in 4 dimensions, but we can visualize color, and we can listen to sound. So maybe the best way to think about it is this point is actually, in the case of 7, let's pick 2. So this would be orange, because that's sort of 2 on an electromagnetic scale. And this would be sort of a deep blue. This is 7. Of course, you could logarithmically kind of adjust the scale so that, you can fit it to certain values. But this could be one way that you can maybe conceptualize 4th dimensions. And people in programming have to do this a lot because you have arrays that could be multidimensional. So, I don't know, just one kind of funny thought. And again, sound works the same way, right? Sound has its own dimension. Of course, we care about spatial dimension, the properties of like non-Euclidean space and how that works, but I still think there's another, like lots of ways, like for Excel, you guys see me in Microsoft Excel a lot, and this is in essence 2-dimensional space, right? And so often, sometimes we'll actually want a 3rd dimension. I'll give you a funny and stupid example, like, and this is a problem with SQL as well, is let's say I had a product. That product is lots of different hats. So I had a New York Mets hat I'm selling. I've got a New York Yankees hat I'm selling. It sells a lot better. I got a Boston Red Sox hat. Who in the world would want that? And then, so this is the x dimension, right? Or you can call it y. You call it whatever one you want. But let's call that x. And let's put that over here. So this is x. And then let's say we wanted to put dates. So let's pick A322. We add 1. And this is the y-th dimension. right? And this is easy. I can plot something for every x and every y, but what something am I trying to plot? We could call that, I guess, you know, the number of hats sold, right? And so we could have some number like this, and I could just generate this with my friend Marock's faker.js tool. I can just do it a little randomly myself. So we got a data set here, and we could plot this pretty easily, right? And I could just say, you know what, I don't like this because I want to also know the dollars sold. And now I have a problem. I can't represent that, right? I can't represent that in 2 dimensions. I'd like to say, well, on 8/4, I sold 3 hats, but how much did I sell them for? Assume each hat was maybe negotiated, or maybe geographic distribution. I could think of an infinite number of dimensions. There's no real way for me to show that. There's also, in options volatility, you have the same issue. So you have a different strike, right? You have expiry up here, right? What else do you have? You got the strike price, you got the expiry, and what else? There's a 3rd dimension, right? Because it's easy to graph those 2. Let's try. We already have strike price. Implied volatility? Well, we got the price of the actual contract, right? So that's how we derive implied volatility. So the expiry sort of serves as the time dimension. The strike price sort of serves as one of the dimensions, and then we have a value that serves as an answer for that, right? So I don't know. There's you can graph 3 dimensions with this as well. In lots of different ways. You could put implied volatility or price, theoretical price, and then the value of the contract. So anyway, we do have to deal with multiple dimensions a lot. It doesn't mean that we necessarily can do it, or we have great tools to do it with. So again, SQL has its problems, NoSQL has its problems. There's no simple way to do this, but understanding the question will help you pick the tool that maybe is the best for you. So anyway, I hope that helps. Some interesting